Okay, guys, today let's talk about formal charge. This is one of the most important concepts that needs to be understood for this course to be a lot easier than it actually is. The lack of understanding formal charge is usually the most common problem that I encounter with my first time tutoring students. It's important because, in one way or another, it tends to drive most reactions because in this course we crave stability. And what I mean by that is a zero formal charge. So zero formal charge means neutral, happy, stable, unreactive. It takes a lot of energy to be reactive, and usually that's going to come in the form of like a +1 or a -1 formal charge. And just like it takes energy to stay mad at somebody, we don't want to use more energy than we absolutely have to. We want to be stable, neutral, happy. That being said, let's get started. So in this course, we're most commonly dealing with these highlighted elements here, and then of course hydrogen on the far left side, these spectator ions. But for the most part, these are kind of the most important elements to understand where they are as far as what column they're in. So that being said, let's start with something like ethoxide. And notice I've got the couple of these highlighted. That's really the one that we're kind of focused on. So this is real easy. So what you're going to do is you're going to write out your ethyl group. And of course, there's going to be a covalent bond between that and oxygen, like that. And so the first thing you're going to do is you're going to fill in any missing lone pairs. Well, how do we know how many to add? So remember the full octet rule. In whether it's tied up in a covalent bond or lone pairs, every element that we encounter needs to have 8 electrons touching it. So if there's 2 here in this covalent bond, 8 minus 2 is 6, and that tells us we're going to add 3 lone pairs. Okay, after that, so now we've completed the octet around oxygen. We're going to do some very simple math. Oxygen is located in the 6th column on the periodic table. So we're going to do 6 minus, and from that, we're going to subtract. We're going to add up all these sticks and stones where everything counts as 1. So 1, 2, 3, 4, 5, 6, 7. So this is going to be 6 minus 7, if my pen will decide to work. Minus 1 charge on ethoxide. Okay, let's try another one. Let's try methanol. So this is going to be a methyl group, covalently bound to oxygen, covalently bound to hydrogen. So we need to fill in the missing lone pairs to complete the octet. There's going to be 2 here, because there's 2 electrons in every covalent bond, two electrons in every stick. 8 minus 4 is 4. So this tells us we're going to fill in 2 lone pairs. Now we've got a full octet around oxygen. Oxygen's in the 6th column. 6 minus 1, 2, 3, 4, 5, 6. 6 minus 6, 0, neutral, stable, happy. Let's try one last example. We've got NH4, so we're going to have a nitrogen, and it's going to be surrounded by 4 hydrogens, covalently bound each. And no missing lone pairs here. 2, 4, 6, 8. No lone pairs needed. Nitrogen is in the 5 column, so 5 minus, and from that we're going to subtract 1, 2, 3, 4, 5 minus 4, plus 1, and that's really all there is to formal charge. The only exception to this rule is when you see something bound to one of these 3 spectator ions, and you'll most commonly see this once you start getting into substitution reactions and elimination reactions. And we're going to do something a little different in that circumstance. So let's take potassium hydroxide. So if you tried to use your traditional formal charge method, you would approach it like this. K, covalently bound to O, covalently bound to H, fill in lone pairs, 6 minus 1, 2, 3, 4, 5, 6, 6, 0, and you'd be wrong. And the reason is that bond between potassium and oxygen is not covalent. It's an ionic bond. So go back to Gen Chem, and we learned about things like cation and anion. So what potassium is in this case is a cation, okay? And then collectively, hydroxide, now there is a covalent bond between O and H. This is your anion. So ultimately, what binds these together is just the electrostatic forces in between them, but it's going to slightly affect how we calculate the formal charge. You're not going to use this method. You're just going to look at the anion here. So you've got O to H, fill in missing lone pairs, you have 3, 6 minus 1, 2, 3, 4, 5, 6, 7, minus 1. And look at that. The shortcut is, if you see anything bound to your spectator ions, lithium, sodium, potassium, the shortcut is cross out that spectator ion, and anything bound to it by default is going to have a -1 charge. And of course, we just proved that with math here. But otherwise, that's really all there is to say about formal charge. If you found this video helpful, please go to our website, orgogoat.com, for more videos. And if there's a concept that you want to see explained, or if you're interested in private tutoring, you can shoot us an email at orgogoat@yahoo.com. Thanks.